Okay, so in this video, we're going to discuss the question for the unit test review for the topic of further algebra. So for this unit test, you're given formulas on the last page here, right? So formula list. It's actually the law of exponent, and we have learned it at school. So I would like you to understand the very basic concept of all of these laws. Okay, so let's just jump to the first question in here. The question is, state this expression in a single index form. So in here, guys, so the first question for question 1a, in here we are just multiplying all of these numbers, right? So you can actually use a calculator, but in here you are going to find and write this down in a single index notation, which means that the form will be like a to the power of n, right? So in order to do that, we must see that if we see like a base that are the same like this one, right? All of the base are 2, right? The number that's being powered is all the same. So we can just like, if you're multiplying, you can just add the power. If you're dividing, you only need to subtract the power, right? So for instance, if I have like 2 to the power of 2 times 2 to the power of 3, that'll be just 2 to the power of 2 plus 3, which is equals to 2 to the power of 5, right? So you don't have to change this into like a number like 32 or maybe like 1024. This is what we call an index form. So the same thing in this one here, we can do it one by one, like the numerator first and then the denominator next. Keep in mind that you need to write down all the process here. So let's just start. I'm gonna do the numerator first. This is 2 to the power of 4 times 2 to the power of 7 times 2 to the power of 12. So it says all of them are have the same base and they're being multiplied, so we can just like add the power, right? So it's 2 to the power of 4 plus 7 plus 12. That's for the numerator. The same thing with the denominator here, actually, right? So all of them have the same base, which is 2, and then we're multiplying, so it means that we only need to add the power. There'll be 2 to the power of 8 plus 9 plus negative 3. Okay, now we only need to add all of these, right? So on the numerator, we have 2 to the power of 23, I think. Yes, it is 23. And then on the denominator, we have 2 to the power of 8 plus 9 is 17. 17 minus 3 is 14. Here we go, right? And then the last one here, we're dividing these two numbers, right? So again, because we have the same base, so which means that we can subtract the power. If you are dividing an index form in which they have the same base, means that you can just like subtract the power. So there will be 2 to the power of 23 minus 14, and be just 2 to the power of 9. Okay, let's go to the next question, number 1b. And here we have the same concept actually like before, but we have the difference between the first and the second question here is that you have some different base, right? So we have 5 of the base for this term, and then this is also 5, but this is not 5, this is 25. This is also not 5, this is 125. So notice that if you have different base, you cannot just add the power. You need to make them, if you can, you have to make the base the same, then you can add or subtract the power. You can add the power if they are being multiplied, and you can divide, you can subtract the power if you are dividing. So for instance, here we have 5 to the power of 3, so let's not change it because 5 is the it's a prime number, so you can't simplify them. And the 25, yes, we can do that. So notice that 25 is actually 5 to the power of 2, right? So we can change that into an index form. The same thing with 125. 125 is equals to 5 to the power of 3. So our first task for this one is to make all of the terms have the same exact base. In this case is 5, right? So change all of the base becomes 5. So this guy, 5 to the power of 3, doesn't change. So I'm going to write down here. So 5 to the power of 3 doesn't change. And then this guy here, 25, that will be 5 to the power of 2, right? So write this down in brackets. So you are going to substitute that 25 becomes 5 to the power of 2. And that power of 2 over here is still there. So it's there. Yeah, okay. Next one here, the bottom here, the denominator 5 to the power of 2, this guy doesn't change, but this guy 125 is 5 to the power of 3, right? So we can change that again into 5 to the power of 3 and then to the power of 4. Can you see that this 4 here is still there? Okay. And then this 5 to the power of negative 10, just leave it like that. This is 5 to the power of negative 10. Okay. So next step is that, again, we can do it one by one. There are so many ways on how to do it, guys. You can just like, okay, if you are used to doing question like this, you can just like add the power. But if you're a beginner, I suggest that you do it one by one. Okay, so if we have like a fraction like this, simplify the numerator first and the denominator, and make them into what do you call it, like a single index form. And if you're multiplying with other terms, then you can multiply that later. So in here, we're going to do this first, right? And then after that, we're going to do this one, and then we're going to combine that with this guy over here. Okay, so let's do it one by one. We're going to do the one on the numerator first. That will be 5 to the power of 3, and then we have this guy here, but we still have a bracket. Now notice that in law of index, if I have a to the power of n to the power of m, there'll be just a to the power of n multiplied by m. So if you have like this, you just multiply the power. So just keep in mind that you really need to understand that we need to have the same base. So in here, we have all of the terms are in the same exact base, which is 5. So 5, 5, 5, 5, 5, right? So after doing that, we can just like, okay, expand the bracket. So and here we're going to expand this one, becomes 5 to the power of 2 times 2, right? 2 times 2 is 4. So that'll be 5 to the power of 3. So I'm going to write this down. 5 to the power of 3, and then times 5 to the power of 4, right? So the same thing with actually the on the denominator, right? So you can just like do it all at once. But remember that you need to know that there are some steps that you cannot do. There are steps that you can, there are steps that you can't do. For this one, yes, we can just, okay, simplify that one. I mean, like, open this bracket over here. There'll be 5 to the power of 2. This guy doesn't change, and then this guy becomes 5 to the power of 12, because this power is 3 and 4, and we know that we can just like multiply them. So 3 times 4 is equals to 12. So multiply by 5 to the power of 12. Okay, so this guy doesn't change, just leave it like that. Then again, guys, we're gonna simplify this first because it's not in a single index form. So in here, it's the same thing like the one with just we did on like the first question, which is just adding the power, right? So this way, right? Adding the power because they're being multiplied. So again, this is being multiplied and they have the same base. So it's just 5 to the power of, like, just let's do it all at once. 3 plus 4 is equals to 7, right? So that'll be 5 to the power of 7. The same thing over here. We have power of 2 and power of 12. Just add them together. 2 plus 12 is equals to 14. So that'll be 5 to the power of 14. And that 5 to the power of 10, negative 10, doesn't change. This one, just leave it there. Okay, next up, we're going to simplify this one, right? The same thing like we did over here, right? So if we're dividing index form in which they have the same base again, you can just like subtract the power. So in here, we're subtracting 7 with 14. Remember, it's 7 minus 14. It's not 14 minus 7. So you subtract the power on the numerator and then with the denominator, yeah? Okay, so that will be 5 to the power of negative 7, right? Because 7 minus 14 is negative 7. So that will be equals to 5 to the power of negative 7, and this guy doesn't change. And then multiply that with 5 to the power of negative 10. Okay, the last one, we can combine this because, again, they have the same base, and because they're being multiplied, so you can just like add the power, right? And that will be 5 to the power of negative 7 plus negative 10. That will be 5 to the power of negative 17. So this is actually the final answer, but if you're being told that you need to have the final answer as positive power like this one, right? So you can actually write it down as 1 over 5 to the power of 17, because we know we have also law of index in which a to the power of negative n equals to 1 over a to the power of n. You can actually change the power from negative to positive or the other way around by just like making them into fraction like this, right? Okay, so yeah, this is the final answer. Then move on to number 2. Again, guys, if you understand the concept when doing question number 1A and B, actually this is not going to be too hard. But the only difference here is that we have 2 of different base. Okay, previously we only have like 1 of the same base, like 2 to the power of something, right? And all of them are have the same base, which is 2. And the same thing with the question B, in which all of the base are 5, like this one here, right? So for this one, we have a different base in which it is not stated as a number, but it is stated as a variable. So remember that variable is actually is a number, a value, in which we don't know yet. So let's just do it. Okay, now in here we have this expression right here. So again, my suggestion is that you do it one by one. Like, okay, you do the denominator, numerator first, and then the denominator, and then you combine them. But if you see that you have like a bracket like this, you can open the bracket first. Okay, so I'm gonna do this one first, and then I'm gonna open the bracket. Actually, yeah, I'm gonna open all the brackets. So the bracket is this guy and also this guy. Yeah. So again, previously we know that a to the power of n to the power of m equals to a to the power of n times m, right? So this guy, the y to the power of 2 to the power of 3, that will be x. This is going to be y to the power of 6, because we know that 2 times 3 is equals to 6. Okay. The same thing with this guy over here. So this guy over here, right? That will be x to the power of 10, because we have to the power of 2 and to the power of 5, and we can just like multiply these two numbers, and that'll be x to the power of 10, and then y to the power of 4. Okay, now the same thing like before, guys. We're dividing things in here, but we have like two different base, right? So make sure that you are combining with the same base. So this guy, oh sorry, the x, this one is going to be combined with this one, right? So and then the y also the same thing for this guy is going to be combined with this one. So let's do it one by one, because again, where they are being divided, right? So you can just subtract the power. So in here we'll have with x to the power of 3 minus 10, right? So for this guy. And then for the y, it's the same thing. We have this one, so there'll be y to the power of 6 minus 4. And as the final result, there'll be x to the power of negative 7, y to the power of 2. So again, guys, if you have like a negative power like this one over here, right, you can actually change this into 1 over x to the power of 7, as I previously mentioned, that a to the power of negative n equals to 1 over a to the power of n. So we can change that x to the power of 7 becomes 1 to the power of x to the power of 7 times y to the power of 2. And if we combine this, we have y to the power of 2 x to the power of 7, because 1 times y squared is just y squared, right? Okay, so yeah, that is the final answer. Okay, and now question 2b. So again, guys, if you understand the concept, pretty easy, all of them, right? So you only need to pay close attention to details and like do it step by step. Okay, so and keep in mind that you need to like check your answer before moving on to the next line. Okay, so for this one, actually the same thing. We're gonna do the one inside the bracket first. So the other things we can do that later. Okay, now we have this one over here, so we can just do this one the same thing like we did for question 2a, and that will be equals to a to the power of 10 b to the power of 4, right? Because this is 2 times 5, which is going to be 10. And then the one on the denominator, that will be a to the power of 7. Sorry, this is equal sign should be over here. And then b, this one here, is 2 times negative 3, which is negative 6. That'll be b to the power of negative 6. And then you put a bracket, and then negative 3, and then times a squared b to the power of negative 4. Okay, so yeah, this is the first step. I'm going to make it a little bit smaller, guys. Okay, that's the first step. The second step is that, again, if you can simplify the one inside the bracket, simplify it. I'm going to simplify this one over here inside the bracket again, and that'll be again because we're doing the same thing like before, like this guy over here, right? So only need to subtract the power because they're being divided. But remember that you need to have the same exact base. So this guy with this guy, so a with a, and then b also with b. Okay, so I'm gonna put it over here. So that'll be equals to, this one is a to the power of 3, right? Because 10 minus 7 is 3. So a to the power of 3. And then this guy is a to the power of 10, because 4 subtracted by negative 6, there'll be 4 plus 6, and they'll be to the power of 10. So b to the power of 10. And we have to the power of negative 3. So this guy doesn't change. It's still over there. And then 8 times a to the power of 2, b to the power of negative 4. Then again, guys, we still have a bracket here, so let's open the bracket. So for this one, the same thing like before, a to the power of n to the power of m equals to a to the power of n m. But if you have like different base, for example, a to the power of n times b to the power of m, and then to the power of p, for example, so this power outside the bracket, you need to distribute that to each of the power with the different base. So this is like a to the power of n times p, and then b also to the power of m times p. Okay, so yeah, so the same thing with this one. So we're going to multiply this -3 to all of this power here, right? So if you do that, we have a to the power of -9, because 3 times -3 is -9, and then b to the power of -3, right? Because 10 times -3 is -30. So yeah, so that'll be b to the power of -30, and then we can rewrite this guy over here. So that'll be multiply a to the power of 2, and then b to the power of -4. Okay, guys, so again, for this final line here, again, all of them are being multiplied. So if I say AB, that will be equal to A times B. You don't really need this sign actually, but it's there so that you know that it's being multiplied. Yeah. So in here, we're going to combine the A and simplify, right? So this guy and this guy, because again, they have the same base, which is A. And then because they're being multiplied, so you only need to add the power, right? So in here, we have a to the power of -9 times a to the power of 2. So which means that we only need to add -9 with 2, and there will be just -7. So for the first one, there will be a to the power of -7, yeah? -9 plus 2 is -7. And then the same thing with the b. And here we have this guy and this guy. So again, just add the power. There will be -30 added with -4. There will be -34. That's it, right? So this is in a single index form, and then we cannot simplify that anymore because we have each of the base have a single form. And actually, again, guys, the same thing like before for this one over here, right? If you have a negative power, you can actually write it down as 1 over, right? A to the power of 7, b to the power of 34. So see that we have negative becomes positive, negative becomes positive. We can change them by making them as a fraction like this. Okay, so move on to number 3. This is not an index form anymore for number 3. This is just a fraction, and you only need to solve for the value of x. Okay, so here we have an equation, meaning that your final goal is to make the variable alone in one side of the equal sign, right? So in here we have x, right? So how can we make them alone in one side? So by doing the same thing on the left side and on the right side of the equal sign, and then yeah, like doing all the process like we always did in grade 7, then you can have the final answer. In here, I'm gonna focus we're gonna focus here on the left side of the equal sign first. And here we can actually simplify this. For example, if I have like 2x plus 3x, instead of like, okay, I'm gonna like do it like one by one, we can actually like combine these, becomes 5x, right? So we're going to do that because all of these two terms have the same variable, which is x, right? So we're going to do it. But again, guys, this is a fraction, so remember, if I say 1 over 2 plus 2 over 3, this is going to be 3 over 5, right? You cannot just like add the numerator with numerator and denominator with denominator. You need to make the denominator the same. That's the first goal. Okay, now in here they do not have the same denominator. They are 3 and 12. So the first thing that we need to do is that we need to find the LCM of 3 and 12. The LCM, the least common factor or lowest common factor, the same thing. And the answer is 12, right? So because 12 are divisible by 3 and 12 also divisible by 12. Okay, and then let's change this into an equivalent fraction in which the denominator is equals to 12. Okay, so I'm gonna write it down, and that'll be over 12, and then plus over 12, they'll be equals to 11 over 15. I'm not going to change this one, just leave it like that. My focus is over here first. Okay, so in here we go 3 to 12, right? So it'll be multiplied by 4. So you also need to multiply this by 4, so that'll be 20x. This guy is 12, and this is also 12, so you don't have to change anything. Or I can say that, okay, this is just multiplied by 1, so multiply also this by 1, you will get 7x, right? Now, can you see that we have the same exact denominator now? After doing that, we can go straight and add the numerator, which are 20x and 7x. In here, we can simplify it. I'm gonna erase this one, guys. Oops, yeah. Okay, so that'll be 27x over 12. Yeah, 27x over 12. 27x over 12. Yeah, this over here, and it'll be equals to 11 over 15. Okay, now we have a single form, right? A single term on the left side and a single term also on the right side of the equal sign. Now, if you have this kind of question, the fastest way in how to do it, we call it like the cross multiplication. So this guy going here, you multiply with that guy, and this guy is going to be going here, and you multiply with that guy. Okay, so let me show you how to do it. Okay, here I'm gonna use a highlighter here again. So I'm going to multiply this with this guy, right? And then on the other side of the equal sign, and this guy with this guy. So the 27x, so the 27x will be multiplied by 15, right? So this guy is this guy. They'll be equals to, remember that the equal sign is very, very crucial. You need to write down the equal sign. So it means that on the right side, there'll be 11 times 12. Right? Okay, now you can actually use a calculator for this one. 27 multiply by 15, that'll be equals to 405. So this is 405x. On the right side, 11 times 12 is equals to 132, right? Okay, the last step again, since we need to make the x alone in one side of the equal sign, so we need to get rid of this. Okay, so by what? By dividing both sides by 405. Remember, 405x, meaning that is this 405 is being multiplied by x. So in order to get rid of this, you need to do the opposite operation of multiplication, which is division, right? So that'll be x equals to 132 over 405. And if we can simplify this, just put all of the numbers into the calculator, and you'll get the simplest form of fraction, which is 44 over 135, and you don't have to change this into decimal. Okay, let's go to question B. Okay, now in here, question B, you can actually do the same thing like we did over here, right? So after you get this form, actually this is the form, right? It's like A over B equals to C over D, right? So it's just like, okay, just we can like do the cross multiplication. This one goes here, this one goes here. Okay, so I'm gonna actually highlight that so you can see what will happen. I'm gonna multiply this with this one, and I'm gonna multiply this guy with this guy. Okay, again, remember guys, the equal sign is very crucial. Please put them. Okay, so in here I'm gonna multiply the 6 with 4x minus 21. Remember that if this is it's not in one term, so you need to multiply everything with 4x minus 21. So you should write it down like the 6 bracket 4x minus 21, right? So this guy with this guy. Okay, and that'll be equals to, remember the equal sign, the equals to, and then we're going to multiply the 5 with 3x plus 15. Okay, that'll be 5 bracket 3x plus 15. See, it's not that hard, right? We do it often when we are in grade 7. So let's do it. I'm gonna make this a little bit small, guys. Okay, so we can have some space. And yeah, just multiply them, and then 6 times 4 is 4x, so that'll be 24x. And then 6 times negative 21, that'll be negative 126. And then 5 times 3x, that'll be 15x. And then 5 times 15 is, I think this is 55. Sorry, 75. Sorry, my bad. 75. Yes. Okay. Now again, guys, the final goal is to make the variable alone in one side. So in here we have this guy here have x, and this is also x, right? So we're going to make all of the x's on the left side of the equal sign, and the other is on the right side of the equal sign. So in here I'm gonna write down here 24, subtract both sides by 15x, they will get 24x minus 15x, right? And then that 75 is not going anywhere, it's just on the right side of the equal sign. We're also going to add both sides by 126. So it's 75 plus 126. Or I can just say it like this. I'm going to move that to the other side. It'll be over here because this is a positive number and it's being added. So it will be subtracted, right? So it's just like the opposite operation of that. And then this negative 226 actually like is subtraction. And if it goes to the other side of the equal sign, it will be addition, right? So subtraction becomes addition. Be careful with that. Okay, now we can simplify this. 24x minus 15x is 9x, and then 75 plus 126 is 201. So the final answer should be divide both sides by 9. There'll be 201 over 9. And if you can just put this into the calculator, this fraction, and then press equal sign, you will get the simplest form of fraction. In this case is 67 over 3. Okay, so for number 4, solve for the value of x. Actually, it's as the same concept with this one. Okay, so for this one, we can do it like this, guys. Remember, we can factorize quadratic. For example, if I have x squared for this one here, x squared plus 5x plus 6, that can be factorized by x plus 2 times x plus 3, right? Because we know that if we do the other way around, we can just like do it the FOIL method. X times x is x squared, and this is plus 3x, and then this is plus 2x, and then this is plus 6. Okay, 3x plus 2x is 5x, and then you will get the same exact form like this, right? So yeah, if you still don't remember, just please open your notebook and then try to learn in how to factorize. Okay, you can just like factorize this one. On the top, on the numerator, we have that x squared plus 5x plus 6, and that can be factorized as x plus 2 multiplied by x plus 3. And on the denominator, we have x squared plus 7x plus 12. For if the method is like this, guys, if you have like the coefficient of x squared is 1, so what you need to think is that you think of two numbers, right? Because this is x squared, so you will have two values. If you multiply, you get 6, but if you add them, you will get 5, right? 3 times 2 is 6, and then 3 plus 2 is equals to 5, right? So that is why it's 2 and 3. Okay, so the same thing with this one over here, right? So think of two numbers. If you multiply, you get 12, but if you add them, you get 7. That will be 3 and 4, right? Because 3 times 4 equals to 12, and then 3 plus 4 is equals to 7, right? So this is 12 and 7. Okay, so which means that we can factorize that, becomes x plus 3 times x plus 4. That'll be equals to 7 over 9, right? Okay, so yeah, in here, because we have the same factor, right, which is this one, we can cancel these two, right? Just cancel them because they're exactly the same thing. So, and then we can rearrange this, rewrite this as x of plus 2 over x plus 4, because that is here and this is over here, right? The one that we haven't canceled yet. And that would be equals to 7 over 9. So can you see that this is actually the same form as the one like we just did for number 3b, right? So we can do what we call a cross multiplication. We can do, okay, multiply this with this guy and this guy with this guy. Okay, and that will be 9 times 2x, x plus 2, sorry, 9 times x plus 2, and then the other one is equals to 7, and then x plus 4. Okay, open a bracket, 9x plus 18, and equals to 7x plus 28. Okay, now again, we can move the 7x here, that will be subtraction. Move the 18 here, that will be also subtraction. And that will be 9x, I'm gonna put it here, so it'll be 9x minus 7x on the left side of the equal sign. And then equals to 28, doesn't go anywhere. On the right side of the equal sign, this guy moves here, becomes negative, or subtracted by 18. And then 9x minus 7x is 2x, and then 28 minus 18 is 10, and x equals to 10 divided by 2, and x equals to 5. Okay, so this is the final answer. Moving on to number 4b, in here we are going to use the same exact method like we just did before, right? So we have quadratic, the numerator and denominator. If we can factorize them and then we can cancel them, let's do that. Okay, so I'll just focus here. Okay, so the 2 here, let's focus that later on. Okay, now again, we need to factorize this. That will be, again, think of a number. If you multiply, you get negative 10, and if you add, you'll get negative 3. And the answer is negative 5 and 2, because negative 5 times 2 equals to negative 10, and negative 5 plus 2 equals to negative 3, right? Negative 10, and then a negative 3. Okay, so which means that we can factorize the numerator as x minus 5 multiplied by x plus 2. Okay, so the same thing with this one. Again, if you think of two numbers, again, if you multiply, you get 30, and if you add, you get negative 11. So notice, guys, in here, you're multiplying two numbers, you get positive, and if you add them, you get negative. So which means that the two numbers will be negative, because negative times negative is positive, and negative plus negative will be negative, right? So yeah, think of two numbers. If you multiply equals to 30, in which that is 5 and 6, right? So 5 times 6 equals to 30, but 5 times 6 is not equal, sorry, plus 6 is not equals to negative 11. It is equals to 11, right? So which means that we only need to add the negative sign in front of the numbers, okay? Okay, again, guys, I'm gonna repeat it again. So negative 5 times negative 6 equals to 30, and negative 5 plus negative 6 equals to negative 11. So 30, positive, and negative over here, right? So again, we can factorize that, becomes x minus 5 and x minus 6. Okay, so I'm gonna erase this. Okay, that will be equals to 2, right? Equals to 2 over here. This 2 over here. Okay. Okay, now the same thing like before. If you see we have the same exact factors, then we can cancel, right? So we can cancel this x minus 5, right? So because they're the same thing, so we can rearrange, rewrite all of this thing without the one that we cancel. That will be x plus 2, this guy, over x minus 6, this guy, equals to 2. Well, actually, for this one, you might be thinking, how can we solve this? What's the difference between that and this one, for example? So, like, both sides are fraction. You can multiply this with this guy and multiply this with this guy. But how about this one? You only have like a number. I mean, like, you don't have any fraction. So actually, you can make this into fraction, which is 2 over 1, right? So you can multiply the 1 goes here and multiply this guy with the 2, right? So yeah, you can do something like this. Actually, again, guys, integers 2 divided by 1 is 2 over 1 is equals to 2, right? So you can just like add like a denominator like this, and yeah, you can still have the same exact answer on the final. Okay, so another way is that, okay, I'm just gonna move this guy here, right? Because it's division. So if I move it to the right side, there'll be just a multiplication, right? So yeah, you can like do the same thing. Okay, so which means that I'm gonna this x minus plus 2 is still on the left side of the equal sign. That'll be x plus 2, and then this guy I'm gonna move that here, and there'll be multiplication. That'll be 2 multiplied by x minus 6. Okay, I'm gonna expand the bracket. There'll be 2x minus 12, and I'm gonna move this x here and this negative 12 here. Okay, so because I want to have a positive value for the x, so the 2 doesn't change. I mean, it's still on the left side of the equal sign. This guy moved to the other way, so that'll be plus 12, and then 12. And then the 2x does not change again. This one is just 2x because it's on the right side of the equal sign. This is x becomes negative x, okay, or subtracted by x. 2 plus 12 is 14, and then 2x minus x is just equals to x. Okay, move on to number 5. And here we have solve for the value of x for this equation. So this time we have an exponential equation in which the variable is on the power, right? So over here. Okay, now for this kind of question, the first thing that we need to make sure is that you have on both sides of the equal sign have like a single index, and they have the same exact base. And here we have this guy, it's a single index form, and it's also a single index form, but they do not have the same exact base. And here we have 2, and in here we have 4. So remember, in the previous question, number, I think it's number 1 or 2, I forget. So we can actually change those. The 4 becomes 2 to the power of 2, right? So again, guys, the goals is that you need to make sure that they have the same exact base. This is 2 and this is 4, so we can change the 4 into 2 to the power of 2. Okay, and then we will have the same base. Okay, now let's do that. So on the left side, we're not going to change anything. It's just 2 to the power of x plus 1. And on the right side, I'm going to change that 4 becomes 2 to the power of 2. Okay, so everything on outside the bracket and outside the 4, just rewrite it again. So 2x minus 7. Okay, now remember again, guys, if you have a power and then it's being powered again, so you only need to multiply the power. So this 2 multiplied by all of this thing. So remember, that is a very crucial thing, because you don't just multiply the 2 with the negative with the 2x, you also multiply the 2 with the minus 7. Remember that we have what we call a distributive. We need to distribute that to x minus 7. So instead, maybe I'm gonna write down like this. I'm gonna write down 2 to the power of x plus 1 doesn't change, and this is 2, and then sorry, I'm gonna use 2 over here, and then to the power of 2, and then bracket to x minus 7. Can you see what happened here? Right, so you multiply this with this. Just remember that you need to put brackets like this. Okay, so let's continue. So on the one on the left side doesn't change, 2 to the power of x plus 1. The one on the right side, we need to multiply it like this, right? So there'll be 2 to the power of 4x minus 14. Okay, now we see that both sides of the equal sign, on both sides of the equal sign, we have a single index form. This is a single index, and this is a single index form, and they have exactly the same base, right? So which means that again, we only need to take the power. This guy equals to this guy, that blue thing, yeah? So let's rewrite again. So that will be x plus 1 equals to 4x minus 14. Okay, so again, I'm just taking the power after I'm making sure that the power are the same on both sides of the equal sign, and they are in a single index form. Okay, now I'm gonna move this x to the right side. I'm gonna move this minus 14 to the left side, and that will be 1. This one doesn't change, right? And then this negative 14 becomes plus 14. And on the right side, 4x does not change, this one, and then this is x becomes minus x over here. Okay, 1 plus 14 is 15. 4x minus x is 3x. So we need to divide both sides by 3. That will be 15 divided by 3 equals to x, and there will be x, which means that will be equals to 5. Okay. Number 5b, now we have this, the same thing like before, guys. But again, guys, the two things that really need to pay attention is that the first step is that to make sure that both sides of the equal sign are in the simplest index form, and like they have only one single index, yeah, single index form. And then when you want to add or subtract the power, like we did before in question number 1 and 2, just make sure that they have the same exact base. If they do not, don't do it. We can try to do it by changing the base into so that they have the same base with the other, so that we can add or subtract. So for this one, we have like 3 terms in here. We have this guy, and this guy, right? So we have 3 of these things, and they are being multiplied. But remember that you cannot just like add this and this, because this is a multiplication, but you need to see the base first. And here we have different base. This one is 3 and this is 9, right? The same thing with this one over here on the right side, and that is 81. So if we can change all of them into so that they have the same base, so change that first. Okay, so the 3, I'm not going to change it because that's a prime number. So the 3 to the power of 2x plus 3, I'm not going to change it. 3 to the power of 2x plus 3. I'm going to change this 9 becomes 3 to the power of 2, right? Because 3 times 3 is equals to 9. So I'm going to change that, becomes a 3 to the power of 2. Maybe I'm going to use other color. 3 to the power of 2. That's the 9. And the power outside is 1 minus 2x. We're not going to change that. 1 minus 2x. Okay. The same thing on the right side. This 81 is actually 3 to the power 4, right? Because we know that 81 is equals to 9 times 9, right? And then 9 is 3 times 3. And this is also 3 times 3. Can you see that we're multiplying 4 of this 3? So that would be 3 to the power of 4. Okay, so I'm gonna write down this guy as 3 to the power of 4, right? And the one outside the bracket, this 5x minus 1 stays there. 5x minus 1. Okay, can you see that now we have all of them are in the same base, but we're not done yet because we need to combine all of them. I mean, like in both of the equal sign, each of them. For this one, we're going to combine this one first, but before we do that, we need to expand the bracket for this one. Okay, remember that this is just a multiplication, so just multiply 2 with 1 minus 2x, and remember that you need to do remember the distributive properties of multiplication. So I'm gonna continue over here. So the 3 to the power of 2x plus 3 does not change. Okay, maybe I'm gonna use red for this one. Okay, 3 to the power of 2x plus 3 does not change, this guy. And then multiply by this guy becomes 3 to the power of 2 minus 4x. Remember, 2 multiplied by 1 is 2. 2 times negative 2x, there'll be negative 4x. And on the right side, there'll be the same thing. There'll be this one and this one, right? So there'll be 20x minus 4. Be careful with that, okay? That'll be 3 to the power of 20x minus 4, because we need to multiply the 4 with 5x and also with negative 1. Okay, so we're almost there. So on the left side of the equal sign, we still have it's not a single index yet, but we can combine them so that they have the same a single index, because we know that they have the same exact base. So because this is a multiplication, you can just like add the power, right? So on the left side of the equal sign, there'll be 3 to the power of 2x plus 3 plus 2 minus 4x. Okay, so again, we can combine these two because they're being multiplied and they have the same exact base. On the right side, we're not going to change anything, 20x minus 4. And then on the right side, I'm going to simplify this. And there'll be 2 minus 4x, there'll be minus 2x. And then 3 plus 2 is equals to 5. Okay, now can you see that we have a single index on the left side of the equal sign, we have a single index on the right side of the equal sign, and then we have the same exact base, which is 3. Okay, now which means that we can just like take the power, this guy equals to this guy, right? Okay, I'm gonna continue on the right side. Okay, so here I'm gonna just take the power. That'll be negative 2x plus 5. It'll be equals to 20x minus 4. I'm gonna move this guy to the right side so that it becomes positive. I mean, being added. So I'm gonna move this to the left side. That'll be plus 4. Okay, maybe I'm gonna highlight that so that you can see what happened. Wait. Okay, I'm gonna highlight this guy and this guy, right? And then the other one is this guy with this guy. Okay, I'm gonna move that minus 2x to the right side, so the 20x stays there, and that'll be plus 2x. Okay, can you see what happened? And then the 5 stays on the left side. This guy, you don't really need to write down the plus, but this guy, negative 4, I mean, subtracted by 4 becomes add with 4. Okay, see what happened here, right? Okay, now we only need to simplify, right? So the one on the left side and the one on the right side. 5 plus 4 equals to 9, and 20 plus 20x plus 2x is 22x. So which means the x is just equals to 9 over 22. Okay, number 6, a rectangle has a perimeter of 38 centimeter. The length and the width are x plus 5 centimeter and x minus 2 centimeter respectively. So this is the length. Okay, the length is this guy, and the width is this guy. Okay, now first question, first instruction, using a ruler draw the illustration of this rectangle based from the information above. Okay, now although we know that the perimeter is 38, but we don't know the length and the width, right? So because we don't know, we can just like approximate, I mean, like, yeah, just make a rectangle, right? And then write down the information that we have from the question. In here, we're gonna just draw a rectangle like this one, and then we're going to write down what we know from the question. In here, just make sure that this is a 90-degree angle, right? Because yeah, and then the length, let's say the length is this guy over here, so that'll be, this one here is going to be x plus 5 centimeter, right? So again, if this is the length, then this is going to be the width, or this one. This is actually the same thing. So let's write down, because we know that the width is this one, x minus 2 centimeters. Just write down x minus 2 centimeter over here. Okay, so that is for question A. Now let's go to question B. Calculate the value of x. Now how can we calculate that? Now, every time you solve any mathematical problems, the thing that you need to do first is that collect the complete information, well, from what is given from the question, and then you try to connect all of them to find the answer. Now, since we know in here the information that we know from the question is this guy over here, right? The perimeter is 38. And now if you go back to grade 7, perimeter is just the length or the distance around a shape, meaning that you are going from one point and then going there, and going to the original place again. So what you do there is just adding all of the side lengths, right? So I'm gonna write down the formula if you know the formula. If you don't know it, that's fine, no problem, right? You only need to understand the concept. It's just like adding this, with this, with this, and with this. That's it, right? Okay, now write that here. So which means that the perimeter, that'll be equals to this, right? X plus 5. And then plus this guy, x minus 2. And then this guy, since this is also the length, so this is also x plus 5, right? So yeah, I'm gonna write down again, that'll be x plus 5. And then the last one is this guy, right? Because this is also the width, so this is also going to be x minus 2. Because this is a rectangle, yeah? Okay, and that will be equals to 38, because we know that the perimeter is 38, right? Okay, now let's try to simplify this guy over here, right? This expression over here. So x, we have how many x? X plus x plus x plus x. There will be 4x. And then we have 5 minus 2 plus 5 minus 2, and it will be plus 6. Okay. Okay, see? Pretty simple, right? Okay, we can do this same thing what we always did in grade 7, right? Solve an equation like this. Subtract both sides by 6. You get 4x equals to 38 minus 6. And 4x equals to 32. And then the last step is to remove that 4. Just divide both sides by 4. And it will be 32 divided by 4. And x equals to 8. And there we go. We have the value of x. Okay. Now, next question is find the length. Okay, so now we know that the length is an expression, which is this one here. Since we already know the value of x, which is 8, so just substitute the x by 8. That's it, right? So keep in mind that you really need to understand on how to write down systematically. So in your answer later, you need to write down like downwards and try to write down what you're calculating at that time. So for question C is the length, right? So we're just gonna write down L. L stands for the length, and it is represented by this expression, which is x plus 5. First, write down x plus 5. And again, since we know that the x is equals to 8, just substitute this x by 8. That's it. So L, or the length, is equals to 8 plus 5, and that'll be equals to 13. And then for this one, you need to write down the unit, right? Because what's the length? It is 13, because in measurement we have unit, right? We can have meter, centimeter, millimeter. So which means that this kind of question is pretty crucial if you do not write down the what they call the unit. Yeah. Okay, same thing with question D. It is asking for the width. So the width is represented by x minus 2. So since we have already know the value of x, which is 8, so you only need to write down, okay, w as the width. Okay, maybe I'm going to use the black one. Okay, w as the width is equals to x minus 2. And again, because we know that the value of x is 8, so just substitute the x by 8. So 8 minus 2, and that will be equals to 6, and that will be in centimeter. Okay, last is the area of the rectangle. Okay, now again, if you go back to grade 7, we know that the concept of the area is just calculating how many squares unit inside the shape, but by just multiplying the base and the height, that's it actually, right? So for question E, that's one, is the area, right? So we know that the area of a rectangle is just like multiplying the length and the width. And since we already know that the length is 13 and the width is 6, so just multiply those two numbers, right? That'll be just 13 times 6, and that will be equals to 78. Okay, then again, guys, you need to write down the unit, which is in centimeter square, because we are calculating how many square inside the shape. Okay, for number 7, it's pretty much almost the same with the previous question, but the difference is that the previous question we have the perimeter. For this one, we have the area. Okay, so let's just read the question again. A rectangle has an area of 550 centimeter square. The length and the width are 2x plus 5 centimeter and 3x minus 8 centimeter respectively. So the length is this guy over here, and then the width is this guy over here. Okay, so using a ruler, draw the illustration of this rectangle based from the information above. Then again, guys, because we don't know the exact length and width, so you can just like draw a rectangle like this. Oops, sorry. Should be, I'm going to use red this time. Okay, here we go. Okay, here we go. So just right, draw a rectangle, and then try to write down what we know from the information from the question. In here we have the length, which is 2x plus 5, so I'm going to put that over here, 2x plus 5 in centimeter. And then this guy here is going to be the length, sorry, the width. That'll be 3x minus 8, 3x minus 8 in centimeter. Okay, now that is for question A. Let's go to question B. Okay, find the value of x. Then again, guys, like we did before, we're using perimeter because the one that is given from the from the question is the perimeter. But this time, you're given the area. So just write down formulas if you know. Okay, so but if you don't know, it's fine, guys. Okay, so the area of a rectangle is just length times width, right? So since we know the area is 550, so that will be equals to 550, right? In centimeters squared. So you don't really need to write down the unit again, guys, because all of the units are the same. Centimeter, centimeter, centimeter. Yeah, we can do that later. Okay, now in here, let's substitute the L, right, with this guy because that's the length, and the W with this guy because that is the width, right? So again, I'm gonna highlight that. The width is this guy over here. That's the width, and then this is the width also. And then wait, I'm gonna use yeah, okay, this one is the length, right? And this is also the length. So what we need to do is just like, okay, I'm just gonna put that over there, right? So I'm gonna just copy this, and then oops, sorry. Okay, wow, wait, ちょっと待ってください. Here we go. So that will be 2x minus plus 5. And the other one is this guy over here, 2x. Okay, so that would be that one, right? And you don't really need to write down the unit for this one, right? So it's just that two thing and being multiplied and equals to 550, right? That one over there. So this one and this one. Okay, now we can like open bracket for this one. That'll be 2x times 3x. That'll be 6x squared, and then this times this, that'll be minus 16x, and this one becomes plus 15x, and the last one is going to be minus 40 equals to 550. Okay, now we have already also learned about solving a quadratic equation, right? So we can simplify all of them so that all of them are on the left side of the equal sign, and then on the other side of the equal sign is just 0. So we can rewrite this as 6x squared, and this one with this one becomes minus x and minus 40, and I'm gonna move this 550 to the left side. It'll be minus 550 equals to 0, and then we can rewrite it again as minus 590, right? Yeah, 590. That'll be equals to 0. Okay, now you might wonder, how can I factorize this? Okay, now you're allowed to use the calculator. So if you have the calculator with you, so use the Casio 991 what do you call it? 991 plus, yeah, I forgot the name. ID or ES is the same thing. Yeah, so this one, go to menu or mode, and then go to number 5, which is equation, or in bahasa Indonesia we call it persamaan, and we go to number 3, in which there will be ax squared plus bx plus c equals to 0, and then you only need to input the coefficient, this one, this one, and this one. It's going to be 6, -1, and -590, and then you will get x1 and x2. So you will get two values of x in here because this is quadratic. Okay, so I'm gonna use my calculator this time. Okay, so I'm gonna use my calculator here. So yours is different, mine is in this. Yeah, so I'm gonna show you that how to get the answer. So you go to menu for this one, and algebra, and then zeros or polynomial tools. Yeah, this one. Find the root of polynomial, and then root of 2, and then yeah, cancel. So that'll be 6, and then -1, and then -590, and okay, and then here we go. So if I'm using my calculator here, so you'll get two values, -59/6 and 10. So I'm gonna write down here the final answer is this one is x1 and x2. So x1 is negative 59 over 6, and then x2 is going to be equals to 10. So we have two values here. So for this context, you need to investigate whether both of them or only one of them is making any sense of this question. Okay, now we have already know that we have length and width, right? So let's say we are going to find the length. So these two are the possible value of x. Actually, we're not done yet with answering the value of b, but yeah. So let's just go to question C. So let's go to question C. I'm gonna add a separator here, guys. Okay, in here question C said that you are going to find the length. Okay, so the length is represented by this expression, right? So I'm gonna write down L equals to 2x plus 5. But we have two values of x in here, right? So we might want to test one by one. So if, for example, if x equals to negative 59 over 6, then the length will be equals to 2 multiplied by negative 59 over 6 and then plus 5. Then again, if you put it in the calculator, that'll be equals to the length will be equal to negative 44 over 3, or we use decimal, it will be around negative 14.7 centimeter. Now in this context, this does not make any sense, right? Because the measurement cannot be negative, right? I mean, like, yeah, if you say what is the length of the ruler, for example, you will have a positive number like 1 centimeter, 10 centimeter, 20 centimeter instead of negative. So which means that this value of x is not make any sense in terms of this context, right? So we're not going to use this value over here. So we can go back actually to question B, in which the possible value of x is just this guy. But we also need to find out whether this also this is going to be true. So let's do the next investigation. What if we have the x equals to 10, right? Because we have this one also included into the answer. So which means that the length will be equals to 2 multiplied by 10. Again, we only need to substitute the 2 by 10 because we are using 10 for this investigation. So and then plus 5, and then you will get 2 times 10 is 20. 20 plus 5 is 2 equals 25. So this is 25 centimeter. Right? Yeah, 2 times 10. Yeah, 25 centimeter. Okay, so does this make any sense? Yes, it is, because this is a positive number and measurement should be positive. So which means that the length is this guy over here, right? So we can make a conclusion for question B that the possible value of x is 10. So you do not include this one because that does not make any sense in this context. So the same thing with this one for question C. Question C. So the conclusion is that the length is 25 centimeter. Right? That's it. Okay. Now let's go to the next question now. It's D, it's the width. So since we know that we cannot use that x equals to negative 59 over 6, then we do not have to investigate it anymore because we already know we cannot use this guy, right? We're going to use this guy. Okay, now let's answer the question for question D. That will be the width, and the width is represented by 3x minus 8 in this question, which is this one over here, right? So just write down 3x minus 8, and since we know that we can use the 10, we cannot use this one, so use the 10. There will be 3 times 10 minus 8, there will be 30 minus 8, and there will be equals to 22 centimeter. Then again, guys, you need to write down the what they call it, the unit. Yeah, and again, guys, this is this makes sense. Yes, it is, because it is a positive number, right? So the width is just this guy over here. Okay, so the last one is the perimeter of the rectangle. So so the last one is for question E. Okay, question E is the perimeter of the rectangle. So again, guys, because since we already know the length and the width, so it's gonna be pretty easy, right? So remember that perimeter is just adding all of the side of this rectangle. We have the length and then the width and the length again and the width again, right? So just add them together. So I'm gonna just write down, okay, 25 plus 22 and then plus 25 and then plus 22, and then you could just like add them together. This plus this is 50. 50 plus 44 is equals to 94, and that will be in just centimeter. Okay, number 8. A rectangle triangle has a dimension as shown below. By using the Pythagoras formula of c squared equals to a squared plus b squared, calculate the possible value of x. Okay, now, again, guys, we can do the same thing like before, right? We have this three-sided triangle, and this is a rectangle triangle. So we can use this formula, right? So this formula over here. Okay, so if you still remember the Pythagoras formula, this is the for this formula is actually the hypotenuse, in which it is the longest side of the triangle. And in this, in here, it will be this guy over here, because we can just like see it. Oh, it's exactly in front of the 90-degree. That will always be the what you call the longest side of the triangle. We call it the hypotenuse. So let's just mark this as C, right? Okay, and then in here, the A and B for this question, for what do you call the factors formula, it doesn't matter which one is it. I mean, like these two can be just A and B. If this is A, this is going to be the B, and if this is the B, and this is going to be the A, it doesn't really matter. So I'm gonna just gonna name this with A, and this is the B. So which means that we only need to substitute everything to this formula over here, right? So I'm gonna rewrite the formula again. That will be c squared equals to a squared plus b squared. So okay, let's start from the c. So the c is this one here, 2x minus 5. So we're going to change this c by 2x minus 5. And remember that this one has a power of 2, so that'll be just to the power of 2. We have equals to, and then the a is this one over here. I'm gonna use different color. Okay, this one. This is the a. That'll be x minus 1. And then again, guys, we have a square over here. This one over here. Okay, the last one is the b. The b is this guy over here, and this x plus 2. Maybe I'm gonna just like do this one, right? So you can see what really happened. This is the c, and this is the c, right? And then this is the a, and this is the a, right? You can see it from here. Okay, guys. Okay, and then the b is x plus 2, right? And then that'll be also in square. Now, the next thing that we need to do is to open the bracket, right? So open this bracket, and open this bracket. So what you need to understand that, guys, if I say 2x minus 5 squared, that is not 4x squared minus 25. No. Instead of, remember that the concept of squaring a number, not squaring a number, actually, like power is like you multiply the thing inside the bracket with itself by the number of time of the power. For example, if I have 2 to the power of 3, right? So what does that mean? It means that you're multiplying this guy 3 times, right? What if I have like 2 plus 1 to the power of 2? The same thing. I'm gonna multiply 2 plus 1 by itself twice, because this is 2, so it's just 2. What if we have 3? So multiply it again, like this, right? So the same thing with this one over here, that if we have like this to the power of 2, meaning that we need to expand it as if 2x minus 5 multiplied by itself twice, right? Okay, the same thing on the right side of the equal sign. This guy is being squared, so you multiply x minus 1 by x minus 1, right? So the x minus 1 multiplied by x minus 1. And the same thing with this one. You're multiplying x plus 2 with x plus 2. Remember, be careful with the bracket and also the sign, yeah, guys? Okay. So let's do it again, guys. The same thing like we always do, like using the FOIL method, right? So I'm not gonna repeat all of them. I'm just gonna go straight to the to the expansion, and that'll be 4x squared, right? And then minus 10x, and then minus 10x again, and then plus 25. And therefore this guy over here. And then maybe I'm gonna move that a little bit to the right so that we can see it. Okay, and then equals to, on the right side we have x times x is x squared, x times minus 1 is minus x, minus 1 times x is minus x again, minus 1 times minus 1 is plus 1. And the last one is this one. So there'll be x times x is x squared, and then plus 2x, and then plus 2x again. 2 times 2, which is equals to 4. Okay, now that'll be, I'm gonna simplify the one on the right side. It'll be 4x squared, and then minus 20x. Okay, I'm gonna combine these two, and then plus 25, and then equals to x to x squared. This one and this one, and then minus x plus 2x. Then the last one is plus 5. Okay, now we're gonna move everything to the left side, and that'll be 4x squared minus 2x squared, and then minus 20x, and then minus 2x, and then plus 25, and then minus 5 equals to 0. So notice that what I'm doing is just like move this guy here, becomes negative, right? And then moving this guy, plus 2x becomes minus 2x, and then moving that 5 becomes negative 5. Okay, then again, we're going to combine all of them. There will be 4x squared, and then minus 2x squared, there will be just 2x squared. And then minus 20, there will be minus 22x. And then there will be plus 20 equals to 0. Then again, guys, you can use the calculator to solve this, but I'm going to do it like this. I'm going to divide all of them by 2. It will be x squared minus 11x plus 10 equals to 0. I'm going to divide all of them by 2. You don't have to do this, but you can do it. All right. Okay, just put everything in the calculator, and you will get x1 and x2. The x1 will be equals to 1, and x2 will be equals to 10. Okay, so you have two values. Then again, guys, you need to investigate two of these values since in terms of the context, right? So just pick one of them. For example, I'm going to pick the c. So if I say the c is equals to 2x minus 5, so if the x is equals to 1, that will be the c, this one here, the length of this line here, there'll be 2 times 1 minus 5, and it'll be equals to negative 3. Then again, guys, negative 3 does not make any sense in terms of this context, so which means that we cannot use the 1. So let's investigate the other one, which is 10. I'm gonna use the same side, which is the c. So if x equals to 10, this guy, right? So that'll be c equals to 2 times 10 minus 5, and that'll be equals to 20 minus 5, and it'll be equals to 15 centimeter. And this, yes, it is makes sense because it's a positive number. So which means that the conclusion is the possible value of x is 10.